Now let's answer question 2. In 2.1, we should start with what we are given. It says the first term of a geometric series is 14 and the sixth term is 448. Now we know that we are dealing with a geometric series instead of an arithmetic and a quadratic. Now it also says that T1 is equal to 14. Remember that T1, the first term, is also denoted by the variable a. Now it also says the sixth term is 448. So term 6 is equal to 448. It says calculate the value of the constant ratio r. It wants r. Remember that our r is given by the ratio Tn over n minus 1. Now in this case, instead of using this formula, we do not have the terms of the series. We only have term 1 and term 6. So what we can use instead is to say, okay, if we know the term and its position, can we try use the general formula for the nth term? Now the general formula for the nth term for a geometric sequence is Tn is equal to a, the first term, times the ratio to the power n minus 1. Now let's try to use term 6. Now if we use term 6, what is the value of Tn? Now we know that the value of Tn is 448 at T6. Now the value of a, which is our first term, is equal to 14, and our ratio, it is what we are looking at. So let's just leave that in there. Now n minus 1, the value of n gives us the position in our sequence, and we know that the number 448 is at position T6. Since we say Tn, so n is 6, so we put 6 minus 1. Now let's simplify. We have 448 equal to 14r to the power 5. We want to leave r on the right hand side by itself, so we are going to divide both sides by 14. Now this 14 will cancel out this 14 and we'll be left with r to the power 5, and on the other side we'll have 448 divided by 14, which is 32. Now to solve for r, we need to find the fifth root of both sides. Remember, what you do on the right hand side, you must also do on the left hand side. Now the fifth root, we say shift. To find the fifth root, we are going to say shift and then put a 5 and then say 32. It will give us 2. So that means that our constant ratio is equal to 2. 2.1.2 says determine the number of consecutive terms that must be added to the first 6 terms of the series in order to obtain 114,674. Now remember that the formula of the sum of a geometric sequence is given by a into r to the power n minus 1 all over r minus 1. So now it says determine the number of consecutive terms that must be added to the first 6 terms of the series in order to obtain that amount of a sum. Now if you need to find consecutive terms that must be added to the first 6 terms to find a certain sum, first we must then find the sum of those first 6 terms. So we are going to look for the sum of the first 6 terms. Remember that when you use Sn, it means that you are starting from the first term. So we are going to find the sum of the first 6 terms, which is equal to the first term in our series is 14. So we have 14. Our ratio, we have found that it is equal to 2, so we put 2. Our n is the number of terms in a series that we are adding, so we have 6 minus 1 all over r, which is 2 minus 1. Now we put that in our calculator and say 14 into 2 to the power 6 minus 1 over 2 minus 1. It gives that 882. So that is equal to 882. Now if you have a sum of 114,674 and you want to find the terms that must be added to the sum of the 6 terms, that means if the 6 terms make up 882, what is left, the difference between this number and 882, that will be the terms that we are looking for. So we take 114,674 subtract 882, it will give us 113,792. Now we know the sum of the consecutive terms that must be added to the first 6 terms, and that is what they are looking for. Determine the number of consecutive terms. But now we want to find how many terms make up this sum, right? We know the sum of those terms. Now how many of those terms are they? Now we know that a sum, we go back to our general formula and say, okay, this is our formula for our series. Now that we know the sum of those terms that we need to add to the first 6 terms, we need to find how many of those terms make up this sum. Now, using the same formula for the sum of a geometric sequence, Sn equal to a to the power r into r to the power n minus 1 over r minus 1. Now what I'm going to do now is substitute what we have now. We know our sum is equal to 113,792 equal to a. A is the first term, but it's not the first term of our sequence. It is not 14. It is the first term after the first 6 terms, meaning that we are looking for term 7. Now to find term 7, we can either use our general formula, which is Tn equal to 14 into 2 to the power n minus 1, and then find T7, which is 14 into 2 to the power 7 minus 1 equal to 14 to the 2 to the power 6. It gives you 896. 896. The reason why we are using this as the first term, because when we look for the sum using Sn says the sum from the first term. Now the first term of this sum is the term after the first 6 terms, so we are talking about term 7. That's one way to find term 7, 896. Another way to find it is by saying term 6 is 448. Now in a geometric sequence, to find the next term, you must multiply it by the constant ratio, which is 2. So which means I can take 448 and just multiply it by the ratio, and it will give me 896. Now I substitute 896 there in space of a. It will be 896 into our r. We know that it is 2 to the power n. We are looking for the number of terms for this new sum. Now minus 1 all over r minus 1. Our r is 2, so 2 minus 1, it will all be over 1. So I'm not gonna write that part. Now to solve for n, let's now detach 896 and divide it. So what you do on the left hand side, you must now do on the right hand side, and on this side will be left by 2 to the power n minus 1. On the side will be left by 113792 divided by 896. It will give us 127. Now we transpose the 1 and take it this side, it becomes positive, so we will have 127 plus 1 is 128, equal to 2 to the power n. Now we solve for n. Some people will use logarithm, but I prefer to come and say 128 equal sign, and then I press shift factors of 2. Now once I press factor, it will tell me that okay, 2 is 128 is 2 to the power 7. So I will have 2 to the power 7 equal to 2 to the power n. If the bases are the same, the exponents are equal. So my n is equal to 7. So I know that the question says determine the number of consecutive terms that must be added to the first 6 terms of the series to obtain this number. So those terms are 7 terms. Now let's move on to question 2.1.3, which says if the first term of another series is 448 and the sixth term is 14, calculate the sum to infinity of the new series. Now we had term 1 as 14, but now we have term 1 as 448 and term 6 as 14. Now let's try to find the new r now, because now they have been inverted. Maybe our r, instead of being 2, it will become 1 over 2. I don't know. Let's check. Now we use the general formula Tn equal to Rn equal to 1 to find the r. Now Tn is equal to 14. We are using term 6. A, which is our first term, 448, and r, which is what we are looking for, to the power n minus 1. And we know that if we are using 14, 14 is position number 6 minus 1. Now we have 14 equal to 448 r to the power 5. We do the same thing that we did in 2.2.1. We divide by 448 on both sides, divide by 448, and then we are left with r to the power 5 equal to 1 over 32. Now to remove the exponent, we just find the fifth root of r to the power 5, and what we do on the left we do on the right. Now you can see that we will be left with r on this side, and then on the right hand side we'll be left with 1 over 2. So it did give us 1 over 2. Now that we have the r for the new series, we can now attempt to find the sum to infinity of the new series. Remember that the sum to infinity is given by a over 1 minus r, especially if r is greater than 0. Now let's substitute. Our first term is 448, the same way we are given here. Remember, our first term is a over 1 minus r, which is 1 over 2. Let's just put it in a calculator and find that the sum to infinity is 896. We are given a sigma notation, k p equal to 0 of 1 over 3 p plus 1 over 6, and they say it is equal to 20 1 over 6. Now if you are given this, they say determine the value of k. Now the value of k in this instant is the upper bound of our sigma notation. Remember that this is our lower bound and P is the index of the sum. Now by upper bound, we're saying if we add, remember sigma finds the sum of whatever general formula you have here. So it must have bounds as to how many terms are we adding up. Now the upper bound will tell you up until term number k, upper bound, from term number whatever number is here, which is the lower bound. So it tells you from which term to which term. So we need to find out from term 0 until term k, what is term k if the sum gives you 20 and a sixth. Now we know the general formula here, it is what is in the brackets here. So now what I'm going to do is, what type of sequence is this that we are adding here? What type of series is this? Now we can see that if we have 1 over 3p plus 1 over 6, this is the same as the general formula of an arithmetic, whereby you have a n plus c. It is a linear where you have a gradient m, you have a variable plus a constant. So we know that we are dealing with an arithmetic series. Now if it is an arithmetic series, then to find the sum of the terms in that series, we are going to use n over 2 into a plus n minus 1 d. Now this is 2n. To substitute into our formula of the sum of an arithmetic sequence, we need to know the sum Sn, and we know that it is 20 and a sixth. We need to know the number of terms. We do not know that. We need to know the first term, and we need to know the common difference. Now let's try to find those. We are going to expand and say, okay, what is the first term? Now the first term a, which is also t1, it is equal to, we are going to substitute what we have here, the lower bound, which the lower bound gives us where to begin. So we are going to substitute 0, p equal to 0. So t1 will be 1 over 3 into 0 plus 1 over 6. This is 0, so a is equal to 1 over 6. Now what is the difference? The difference, we'll have to find also t2 and say, okay, term 2 is 1 over 3 into, remember that from the lower bound you must move one integer upwards until you reach the upper bound, which means that from 0 we go into 1 plus 1 over 6. Term 2 is 3 over 6. Now since this is an arithmetic, d, which is the common difference, we find it by taking term 2 and subtracting term 1. Our term 2 in this case is 3 over 6, and our term 1, it is 1 over 6 from here, and that difference, it is going to be 1 over 3. Now that we have the difference, the first term, we can now go and find out what is the number of terms, which is exactly what we are finding out, the upper bound. Now let's substitute Sn. Sn is the sum itself, which is given by 20 and a sixth, and a 20 and a sixth is 121 over 6. Let me actually use 121 over 6 equal to, we don't know n, so we'll have n over 2 into 2 into a. A is our first term, so we know that a, it is 1 over 6 plus n minus 1. We still don't know n, so it's n minus 1 into d. And we know that our d is our common difference, which is 1 over 3. Now, all we have to do in this case is just solve for n. Now, to solve for n, we can expand that. We have 121 over 6 equal to n over 2. This is 2 over 6, which is just 1 over 3, plus expand here. By expanding, 1 over 3 is going to multiply n and multiply 1. So we are going to have 1 over 3n minus 1 over 3. Now, 1 over 3 will subtract 1 over 3 and we'll be left with 1 over 3n. So that gives us, that is to say, 121 over 6 is equal to 121 over 6 is equal to n squared over 6. 2 times 3 will be 6. N times n will become n squared. Now the 6 can cancel each other, so we are left with 121 equal to n squared. So what I'll just do is find the square root of both, and then our n is equal to 11. Now that we know our n is equal to 11, we know that if we have 11 terms, that gives us 20 and a sixth from this general formula. Let's come here so that we can solve it properly. Remember that the number of terms of a sigma are given by the upper bound, which is k in this instant, minus the lower bound, m. It's represented by m, so we know that it's 0 plus 1. That is the number of terms in a series. So we want k and we know n. That means k minus 0 is k, plus 1 is equal to n. We found out that our n is 11. So our k will be 11 minus 1, which is 10. So our upper bound is 10. You need to practice this thing and remember that the number of terms n in a series, it's given by the upper bound k minus the lower bound m, and they plus 1. And that is exactly what I did here, so that I can find that k is actually 10. It's actually 10 because this is 0 here. If p started at 1 instead of 0, it will probably stay as 11. But since it started at 0, it becomes 11. And we showed that by using the formula of the number of terms in a sequence using sigma. It's found by using that formula.